So here we have a Whirlpool electric dryer, and the complaint of this dryer is that it does operate, but there's no heat being produced. This particular dryer, it's a Whirlpool, it's a model, let's see if I can get WED4800XQ0. Tough to see that, but I will fire up the dryer and just verify that that complaint is correct. So we'll turn the dial. Temperature will go to high, and we'll cycle, let's see, push to start, and we'll let the dryer run for a minute. I hear obviously the motor's running, the basket inside is going, and we'll just wait and see if we have any heat being produced from the dryer. Okay, that should have run long enough to create some heat, and sure enough, the dryer is cool. So I will walk you through how to troubleshoot a no heat on this Whirlpool electric dryer. Okay, so the first thing we have to do is we have to remove the 1/4-inch hex head screws that are holding the back panel on. It looks like there are 7 screws altogether, and to remove those we just use a nut driver on our drill driver. Okay, so the back panel has been taken off. I still have the unit plugged in, so our electrical terminals here are live, so be cautious there if you leave the unit plugged in. Here's our air duct. The electric heating element connections are down there. This is a high limit thermal fuse. There's also a high limit cutout that is wired in series with the element. There's a thermal fuse, and that is the operating thermostat, the black part. So we'll go through, I will show you the wiring diagram, and we'll go through how all of these are connected with each other. Everything is wired in series with the electric heating element. So these are all safety switches. If something were to go wrong, if the motor wasn't turning, or if this air duct was full of lint and it was restricting airflow, if there isn't any airflow, it cannot dissipate, it cannot blow the heat away that the heating elements are creating. So it would overheat, and those safeties are there to prevent a fire or overheating of the dryer. So I also want to show you, so I did run the dryer and I just checked temperature by feel with my hand. I ran the dryer for a minute and opened the door, put my hand in there, and it was cool. That's not the most accurate way in the world to check to see if your heating element is operating or not. So I would like to show you the way that you need to do it to verify absolutely that the heating element is not energized and heating. Okay, the way we are going to make certain that our heating element is not energized is with our voltometer, our multimeter. We are going to take an amp draw of the wire going to the heating element with the heating element with the dryer running. So the heating element should be energized here, and it should be operating, it should be pulling amps. So we'll check that now. So I turn my meter to my amp setting, and I will go ahead and clamp it. Go ahead and clamp it around the electrical supply wire going to the heating element. I will turn the dryer on, and we'll see if we have an amp draw from that heater. Okay, so the dryer is running, and taking a look at the meter, 0 amps. So I'll show you the next step in diagnosing. Okay, so the next step, we determined that there are no amps. The heater's not drawing amps. So we have to determine the condition of that heating element. The first question I have in my head right now is whether or not that heating element is open or if it's closed. So I'm going to take a resistance measurement of the electric heating element. To do that, first thing we do when we take resistance is we disconnect power to whatever we are checking. So I'm going to go ahead and do that. Okay, so I have the cord unplugged to this unit, so there is no power. I want to check resistance of the electric heating element, and the heating element are the terminals with this that are part of this white porcelain insulator. So I'll have to unplug the wires off those terminals, and then we'll turn our meter to the ohm setting and we'll check resistance of that heater to make sure that it does have resistance and that it's not an open circuit. Okay, I have my electric meter set on the ohm setting. I have it set on the ohm scale, and I do have the audible beep activated. So if this heating element is not open, it will give us a beep. Okay, so our heating element is not open. We're reading 9.7 ohms. So our heating element is good. The next step is to check this high limit cutout, high limit thermostat, as well as this high limit fuse. Before I do that, I wanted to show everybody the electric heating element. So the terminals we just tested are right here where the spade terminals come out of the porcelain insulator. So if you look closely, that's where the heating element wires are connected to. So it's one continuous loop. Electricity comes in one side and it follows these metal coils, and there's a back row as well. It goes all throughout the back row and comes back out this wire. Okay, the next thing I want to check is this. It's called a non-resettable thermal cutout. So if this air duct were to get plugged up so there wasn't enough airflow, or if the operating thermostat failed in the closed position and the heaters kept heating and heating and heating, this high limit thermal cutout would open. It would stop electricity flow to the electric heating element. So I have the wires disconnected. I have one of my meter leads connected here, and my other lead, we're just going to check to see if this cutout is open or closed. All it is a switch. You hear the beep, we have continuity, this thermal switch is closed. So that is not our problem. Okay, the next thing in series with the electric heating element is our operating thermostat. And I have it isolated. I have the wires disconnected. I have my red meter lead with an alligator clip already clipped on one of the terminals. Take my other lead, and we should have continuity if this is closed. Okay, the meter's beeping. We do have continuity. Our operating thermostat, which is in series with our heating element, is closed. So that also is not what's keeping our heating element from being energized. So as we determined from looking at the wiring diagram, there are two other things that are in series in our heating circuit. We talked about the timer switch being one of the items, and the centrifugal switch on the motor being the other item. So I am not an appliance repairman by any means, so I had to trace the wiring, and I see that the wiring looks like a bear to get to in order to check the centrifugal switch on the motor. And the timer switch is up on this back panel, and it appears that I only have to take out 5 screws here to get to that timer switch. So we'll check the timer switch first, and we'll see if the timer switch is closing like it is supposed to be closing. Okay, I have the back panel off, and we have easy access to our timer switch. When I trace the wiring, when I look at the wiring diagram and I trace the wiring for the heating element, I can tell that it's the first red wire and the third black wire is what is sending electricity to the heating element. So I will I'll go ahead and unplug this plug. We'll unplug the plug. Again, I'll be setting my meter to read continuity. I'm hooking up one of my leads with an alligator clip just to give me a free hand, and I will take my other meter lead, so it's between terminals 1 and 3, and right now we should have continuity because the timer switch is still on from before, but I'll turn it to a different setting just to make certain, and I have 0 continuity. That switch is open. Our timer switch is not closing, so it is not sending electricity to our electric heating element. I think we found our culprit here. We'll have to replace this timer switch. Okay, I've got a new timer switch, and just to be certain, before we go through the trouble of putting this in, I'm going to make sure the contacts on this switch are closing. So I have the dial turned. I have my red meter lead with an alligator clip clipped to that spade terminal number 1, and I'll place my other meter lead on spade terminal number 3, and the set of contacts in there, that switch should be closed. And it is. We're getting the audible beep, so our new timer switch is doing what it needs to do. So we'll go ahead and get that put in. Alright, so I know it looks the exact same, but I have the new timer switch installed on this dryer. So the next step is to plug it in, start it up, and see what we have for an amp draw on our heating element. So I'll go ahead and get my amp probe, my amp meter installed on that. I'll plug the dryer in and we'll see what we have for an amp reading. So in a nutshell, that is your basic electric heating operation.